Before people lived on Earth, animals left behind fossils that were so shocking that even experienced paleontologists were shocked by what they showed. Scientists had to face a scary truth when they found bus-sized snakes, millipedes as long as cars, and clawed dinosaurs that looked like they were straight out of a nightmare. The past was full of monsters that were stranger and more dangerous than we could have imagined. Spinosaurus, the crocodile-snouted river monster. In the early 1900s, paleontologists found the bones of Spinosaurus aegyptiacus in the Egyptian desert. They had no idea they were looking at the bones of an animal that would change the way dinosaurs hunted. The pieces showed a predator that was unlike any other known predator. The huge vertebrae had tall neural spines. The head looked like a crocodile's and was lined with conical teeth, and the limb bones pointed to a giant bigger than even Tyrannosaurus rex. But before scientists could put together the whole picture, most of the fossils were killed during an Allied air raid on Munich during World War II. Drawings, accounts, and a puzzle that lingered in paleontology for decades were all that were left. For much of the 20th century, Spinosaurus was treated as a shadow among giants. Scientists imagined it as a classic land predator, a desert-dwelling rival to T-Rex, striding across ancient floodplains in search of prey. But the more fragments emerged, from Morocco, Algeria, and later digs, the stranger the animal became. Its jaws were long and narrow, lined not with slicing teeth but with cones designed to grip slippery prey. Its nostrils were placed higher on the snout, as if to allow breathing while partly submerged. And most famously, the elongated spines on its back supported a massive sail or hump, the purpose of which is still debated today: display, thermoregulation, or even aquatic stability. Then came the game-changing discovery in the early 2000s. New fossils from Morocco that revealed Spinosaurus had shorter hind legs than expected. In fact, they were oddly stubby compared to the towering proportions of other theropods. Combined with evidence of dense bones, much like those of modern aquatic animals, paleontologists began to argue that Spinosaurus wasn't just a river's edge hunter. It was a semi-aquatic predator, a dinosaur that lived much of its life in water. This revelation was terrifying for a simple reason. It meant that Earth's largest known carnivorous dinosaur wasn't roaming the land like a traditional apex predator, but ruling the rivers like a reptilian nightmare. Consider a dinosaur that is 50 feet long, has crocodile-like teeth that can break bones, and a sail that cuts through the water like the fin of a huge fish. Spinosaurus ate big fish like sawfish relatives and giant coelacanths, which were found in its stomach contents. Other dinosaurs that got too close to the sides of the river could have been easily attacked by this one because it was big and strong. Spinosaurus crossed the line between being a predator in water and a hunter on land. This was a role in development that almost no other dinosaur played. The sail itself only deepened the mystery. Was it a signal to intimidate rivals or attract mates? A way to absorb and regulate heat? Or could it have functioned like a rudder, stabilizing the animal while swimming? Even today the debate continues, with computer models and biomechanical studies offering competing theories. What paleontologists agree on is this: no other giant predator looked anything like Spinosaurus. It was a one-off design in evolution's experiment book, and it worked well enough to dominate river systems of Cretaceous North Africa. For decades, T-Rex had held the cultural crown as the most fearsome dinosaur of all time. But Spinosaurus was longer, stranger, and perhaps even deadlier in its own environment. Suddenly, the story of prehistoric predators was no longer straightforward. The world of the dinosaurs wasn't just about giant land hunters. It was about bizarre, specialized monsters adapting to niches we never imagined. That realization forced paleontologists to confront how incomplete the fossil record really is. If a semi-aquatic predator the size of a bus could remain misunderstood for nearly a century, what else was waiting in the rocks, half buried and misinterpreted? Even now, reconstructions of Spinosaurus stir debate. Artists and scientists wrestle with its proportions, its swimming style, and even how it moved on land. Did it lumber awkwardly when out of water, dragging its belly across the ground? Or could it rear up and chase prey, crocodile-like, in explosive bursts? The uncertainty itself is unsettling, because it means that our understanding of one of the largest predators in Earth's history is still incomplete. For paleontologists, Spinosaurus is both a great find and a scary warning of how fragile life is. The fact that the original fossils were destroyed by war shows how much information can be lost in an instant. Every new find since then has been like a piece of a puzzle, slowly showing a monster that looks stranger as each piece is added. Its presence is scary not only because of what it was, a river-dwelling top predator with a crocodile-like nose that was bigger than T-Rex, but also because of what it stands for, the unknown that was just below the surface of prehistory. Megalodon teeth, proof of a giant shark. Strange preserved things were found all over Europe and the Americas for hundreds of years. They were ridged and jagged and looked like triangle stones. Sometimes they were bigger than a man's hand. Farmers called them tongue stones, because they thought they were the dragon or snake tongues that had hardened. Some were worn as charms against poison in the Middle Ages. Scientists didn't understand the truth until the 17th century, when paleontology began. These weren't tongues at all, but teeth from a shark that was so big, it dwarfed anything that swims in the seas today. The shark was later named Paraceratherium Megalodon, or just Megalodon, which means big tooth. The size of those teeth told the whole story. Great white sharks today have teeth that are about 2 inches long on average. Megalodons were at least 7 inches long, which is longer than a human palm. Fossil hunters quickly figured out that the mouth had to be huge in order to hold those teeth. A grown person could have stood inside it without any problems. How strong was the bite? It is thought to be more than 40,000 pounds per square inch, which is strong enough to crush a car, and more than 10 times the weight of a cat. The terror came not just from the size of this predator, but from its abundance. Megalodon teeth have been found on every continent except Antarctica, preserved in ancient seabeds and riverbeds. They suggest that for nearly 20 million years, Earth's oceans were patrolled by a predator up to 50 or even 60 feet long, twice the size of the largest great white sharks alive today. Imagine a school bus with fins, its gaping jaws ringed with hundreds of serrated knives, each designed to shear through flesh and bone. Paleontologists have pieced together its diet from fossil evidence. Megalodon preyed on whales, seals, dolphins, and other large marine mammals. Fossilized whale bones have been found with puncture marks that perfectly match the spacing of Megalodon teeth. In some cases, bite marks wrap around an entire vertebra, proof that this shark didn't just scavenge, it actively hunted whales. The thought of an apex predator capable of dragging down a full-grown whale was deeply unsettling, even to scientists accustomed to studying giants of the past. But there was another twist in the teeth. They showed how recent Megalodon's rule really was. This monster wasn't a fossil from the Jurassic or Cretaceous like Spinosaurus or Pliosaurus. It was at its best from about 23 million years ago to about 3.6 million years ago. In terms of development, that means it swam in the seas of Earth not long ago. Early humans, like Australopithecus, may have lived in the sky above the seas, where Megalodon was still hunting. The thought of such a monster existing so close to our own time made it seem less like something from the past and more like a nightmare that we had just barely escaped. Megalodon is terrifying in part because it is mysterious. While dinosaurs sometimes leave behind almost whole skeletons, sharks' skeletons are made of cartilage instead of bone. This means that almost nothing of Megalodon's body has been found except for its teeth and a few vertebrae. Scientists and artists try to figure out what it looked like by comparing it to current sharks, but the argument goes on. It looked like a big great white shark, or it might have been a hunter that was more like a basking shark crossed with a bulldog. There isn't a clear answer without a full skeleton. This creates a monster whose true look is still unknown, which makes people even more scared of it. Then there's the cultural shadow Megalodon casts. Myths and stories have been going around for decades that Megalodon might not really be dead. Unusual bite marks on whales, sonar readings that couldn't be explained, and reports of sharks that were too big to be real all led to discussion. Documentaries and horror movies played on this fear by showing Megalodon as a monster from the deep that was still waiting below. Megalodon is not alive today according to science. However, the fossil teeth that can be found on beaches and in riverbeds are proof that it existed. and that no amount of hopeful thinking can change the truth about what it was: an incredibly large and dangerous top predator. Paleontologists find it both amazing and horrifying to hold a megalodon tooth. It's one thing to look at the bones of long-dead animals that lived a long time ago. It's a different thing to study a predator that lived in seas very similar to ours, 8 animals we still recognize, and died out not long ago. Each tooth is more than just a fossil. It's a piece of proof that the seas around Earth used to be home to a killer that we can't even imagine. Arthropleura tracks, the giant millipede. Geologists were studying a sandstone beach in northern England in 2018 when they found something so strange that it made news around the world. Huge ancient trackways were carved into the rock. They looked like parallel tracks that were several feet across. At first glance, it looked like a cart had pulled them across the soft sand. But as scientists looked more closely, they found out the scary truth. These were the tracks of Arthropleura, an extinct millipede relative that grew longer than a car. Arthropleura lived during the Carboniferous period, over 300 million years ago, in a world very different from today. Dense swamp forests covered much of the land, and the air was rich in oxygen, nearly 35% compared to the 21% we breathe today. That elevated oxygen level didn't just make fires burn hotter, it also allowed arthropods and insects to grow to monstrous sizes. Dragonflies the size of seagulls buzzed through the skies. Scorpions stretched several feet long, and in the undergrowth, millipedes the length of crocodiles scuttled across the forest floor. The trackways revealed in England were nearly 3 feet wide, and the creature that left them likely measured over 9 feet long and weighed several hundred pounds. This wasn't the millipede you find curled up under garden soil. This was a colossal crawler, armored with segmented plates, and capable of navigating through the tangled roots and decaying plant matter of the swamp forests with ease. Imagine hiking through ancient woods and seeing a creature as long as a car and as wide as a coffee table wriggle across your path. Even seasoned paleontologists admitted that the scale was unnerving. What made Arthropleura especially terrifying was not just its size, but its mystery. Unlike many large prehistoric animals, complete body fossils of Arthropleura are rare. What we know about it comes mostly from trackways, isolated body segments, and indirect comparisons with its modern relatives. This lack of a full skeleton leaves much of its biology uncertain. Did it behave like modern millipedes, harmlessly munching on decayed vegetation? Or was it opportunistic, capable of feeding on small animals that strayed too close? Some paleontologists lean toward the herbivore theory, noting the abundance of plant matter in the Carboniferous forests. Others suspect that an animal of such size may have been more versatile in its diet. The truth remains hidden in stone, fueling speculation and unease. The environment that allowed Arthropleura to grow so large was itself alien compared to today. The Carboniferous forests were damp, dark, and choked with giant ferns, horsetails, and club mosses. Trees soared without flowers or fruits, their bark-like trunks stretching into canopies of strange greenery. The high oxygen content not only encouraged the growth of giant arthropods, but also created ecosystems prone to wildfires, with flames sweeping through the swamps in ways we would barely recognize. In this setting, Arthropleura thrived as one of the dominant land animals, perhaps the largest land invertebrate to ever exist. When paleontologists first measured the tracks, they couldn't help but marvel at the engineering of this creature. Its dozens of legs, moving in coordinated waves, would have carried its armored body smoothly across the ground. Unlike vertebrates, it had no bones, but relied on a tough exoskeleton. The sheer weight of such a body, supported only by chitin, would have been staggering. And yet, the fossil tracks show it moved efficiently, leaving behind crisp impressions that lasted for hundreds of millions of years. For modern scientists, the discovery of these trackways was more than just a curiosity. It was a reminder that Earth's history is filled with evolutionary experiments that defy expectation. The thought of a 9-foot-long millipede crawling through a forest unsettles us, not because it was predatory, but because it is so far removed from anything we see today. The gap between the tiny millipedes in our gardens and the armored behemoth of the Carboniferous is almost incomprehensible. That contrast forces paleontologists to reckon with how radically life can change when environmental conditions shift. Also, the fact that Arthropleura fossils are so rare shows that we still don't know a lot about its world. Each new trackway or section only gives us a small taste of its life. Did it shed its skin like modern arthropods do? Did it dig holes for itself or spend most of its time outside? Did it go in groups or by itself? It's scary to think about how much of prehistory is still unknown. Every question makes us feel more uneasy. As the Carboniferous period ended and the Permian period began, the Arthropleura finally went away. The end of big arthropods was sealed when swamp woods dried up and oxygen levels dropped. We are kind of lucky because moving giants might still live on our world if oxygen levels had stayed high. Lots of people get chills just thinking about it, because the thought of a forest floor ruled by giant insects and their relatives is very disturbing. Deinocheirus claws, mystery monster arms. In the Gobi Desert in 1965, a group of Polish and Mongolian paleontologists made a find that would stay with them for almost 50 years. They found two huge fossilized arms, one over 8 feet long and finishing in bent claws that were as sharp as sickles. The rest of the skeleton wasn't there. There was no head, no body, and no legs. Just two huge arms lying in the desert sands. The dinosaur that had them was named Deinocheirus mirificus, which means unusual terrible hand. For many years, those arms were one of the biggest puzzles in the field of geology. At the time, the implications were terrifying. No dinosaur with arms that large and claws that massive had ever been discovered. The arms dwarfed those of known predators like Tyrannosaurus rex, which, famously, had almost comically short forelimbs. Paleontologists speculated that the owner of these limbs must have been a predator beyond imagination, a killer with a body even larger and more dangerous than T-Rex. For years, illustrations and reconstructions depicted Deinocheirus as a towering carnivorous monster stalking the Cretaceous floodplains of Mongolia. It was a nightmare made plausible by science. But as more discoveries came in, the picture grew stranger. Fossils of related dinosaurs, the ornithomimosaurs or ostrich mimics, suggested that Deinocheirus might not have been a predator at all. Could those claws have belonged to a giant herbivore instead? The idea seemed absurd. Why would a plant-eating dinosaur need scythe-like claws longer than a man's arm? Still, without a complete skeleton, the debate raged. Was Deinocheirus a super predator lost to time or a bizarre experiment in dinosaur evolution? The answer finally arrived in 2014, nearly 50 years after the first discovery, when a more complete skeleton of Deinocheirus was unearthed. What paleontologists revealed shocked the world. Far from being a streamlined predator, Deinocheirus turned out to be a bulky, humpbacked giant with a duck-like bill, massive arms, and an oddly rounded back. Its claws, once thought to be weapons of destruction, were likely used for digging and foraging, pulling down branches, stripping vegetation, or scooping plants from wetlands. The predator of nightmares was actually one of the strangest herbivores ever found. Evidence suggested that Deinocheirus was semi-aquatic, spending much of its life around rivers and lakes. Its wide, duck-like snout hinted at a feeding style closer to that of a waterfowl than a killer dinosaur. Fossilized stomach contents confirmed this, containing fish remains mixed with plant matter. Deinocheirus wasn't hunting other dinosaurs. It was fishing and browsing, using its giant claws not as weapons, but as tools. And yet, even with the truth revealed, the unease never fully went away. Those claws, over 3 feet long, were still formidable enough to defend against predators. The arms themselves, powerfully muscled, were unlike anything else in the dinosaur world. And the sheer size of the animal, it stretched nearly 36 feet in length and weighed up to 6 tons, meant it would have been an imposing sight on the ancient floodplains. Imagine a humpbacked dinosaur with a bill like a duck towering over you as it rakes through vegetation with claws longer than swords. Even without predatory intent, its appearance alone would have been enough to send a chill down the spine. Titanoboa vertebrae, the snake that ate crocodiles. In 2009, paleontologists found something that stopped them in their tracks deep in a coal mine in northern Colombia. At first glance, it looked like a huge tree branch that had turned into stone. But when I looked more closely, it wasn't wood at all. That thing was a spine. It was thick, heavy, and from an unimaginably big snake. That bone and dozens more like it told the story of Titanoboa kerajanensis, the world's biggest snake, which was over 42 feet long and weighed more than a ton. Because it was so big, it could have been eaten by crocodiles, giant turtles, and even small dinosaurs. For scientists used to handling fossils of large animals, the scale was almost incomprehensible. Modern anacondas and reticulated pythons can reach lengths of over 20 feet. Impressive, but not world-shattering. Titanoboa was double that length and many times heavier. Imagine a snake as long as a school bus, its body as thick as a human waist, sliding silently through a swamp. Paleontologists quickly realized they were looking at an apex predator unlike anything alive today. The discovery of Titanoboa was tied closely to the ancient environment of its home, the Paleocene epoch, about 60 million years ago. This was a time just after the extinction of the dinosaurs, when mammals were still small and ecosystems were rebuilding. In tropical South America, vast swamps stretched across what is now Colombia, filled with enormous crocodile relatives, giant fish, and turtles larger than car tires. Titanoboa ruled this environment with absolute dominance. Fossil evidence even shows that crocodile-like reptiles from the same coal mine bore bite marks consistent with the crushing coils of an enormous snake. Scientists are extremely intrigued in Titanoboa's size because it gives them clear proof of how the climate was in the past. Snakes and other cold-blooded lizards depend on the temperature outside to keep their bodies warm. A 42-foot-long snake could only live in places where the average annual temperature was at least 90 degrees Fahrenheit. To put it another way, Titanoboa showed that tropical areas in the Paleocene were much hotter than they are now. This changed how we think about Earth's temperature after dinosaurs. The fossil wasn't just a skeleton, it was also a thermometer that had been set in stone. But Titanoboa's way of killing is what really disturbs people. It didn't have poison like current constrictors do. Instead, it was based on muscle power alone. Scientists think that its coils could put over 400 pounds of pressure on a square inch of its food, which would be more than enough to stop its blood flow right away. It was impossible for the animal to get away once it was wrapped around a crocodile, big fish, or turtle. The snake could swallow whole animals because its lips were double-hinged and had recurved teeth. Its body could stretch and expand to fit meals as big as a grown cow. Visualizing Titanoboa in action is what unnerved paleontologists most. Unlike dinosaurs, which often seem like distant alien creatures, Titanoboa's body plan is familiar. It looked like snakes we know today, only magnified beyond belief. There's something visceral about the idea of a snake that long and that strong silently moving through the water, almost invisible until it struck. And because it lived in swamps, paleontologists picture it lurking in murky water, waiting with only its nostrils above the surface before launching at unsuspecting prey. The fossils of Titanoboa came largely from the Cerrejón coal mines, one of the largest open-pit coal operations in the world. Ironically, mining that disrupted ancient layers of earth led to one of the greatest fossil finds in decades. Among the snake's remains, paleontologists also found a diverse community of giant reptiles, fish, and plants, painting a vivid picture of the lush, steaming ecosystem where Titanoboa thrived. It was not an isolated monster, but the apex predator of an entire world. The discovery has also fueled debates about how Titanoboa moved. Could a snake of that size have survived purely on land, or was it limited to the water? Many paleontologists argue that Titanoboa's sheer bulk would have made terrestrial movement clumsy and exhausting. Instead, it likely spent much of its time swimming, its body supported by water, where its size became an advantage. This aquatic lifestyle would also explain how it ambushed crocodiles and giant fish. It wasn't a land predator stalking forests. It was a swamp dweller, a silent shadow beneath the surface. Therizinosaurus claws, nightmare farming tools. Soviet paleontologists were working in the Mongolian mountains in the late 1940s when they found a set of fossil claws that were unlike any other they had seen. Each claw was more than 3 feet long, which is longer than a man's arm. They were bent like a scythe and had a very sharp tip. At first, no one could even guess what kind of animal they were. It was known that dinosaurs had claws, but not this big. These were horror tools. The talons were so big and sharp that they looked like they were only meant to kill. The creature was named Therizinosaurus cheloniformis, meaning scythe lizard. The name alone reflected the unsettling power of those claws. Early paleontologists speculated that Therizinosaurus was a giant turtle crusher or some kind of monstrous predator. The claws were imagined as weapons for slashing through flesh, tearing apart prey, or fending off other dinosaurs. Artists of the mid-20th century depicted it as a fearsome killer, towering over its rivals with talons poised to strike. For decades, the true identity of Therizinosaurus remained shrouded in speculation and fear. Since there was no full skeleton, the question grew. Scientists had a rough idea of what the monster looked like, but not a clear picture of its body plan, because the first skeletons only had claws and parts of limbs. Those claws sparked thoughts without any other information. Paleontologists weren't sure if the fossils belonged to a huge hunter, a Tyrannosaurus relative that was too big, or even a strange animal that looked like a turtle. Stranger things would happen than they seemed in the story. It wasn't until the 1970s, and later, when more fossils were found in Mongolia and China, that paleontologists began to piece together the real picture. Therizinosaurus wasn't a predator at all. Instead, it was part of a group of theropod dinosaurs known as Therizinosaurs, which were plant eaters. These animals had long necks, pot-bellied torsos, and small heads with beaked mouths, features suited not for hunting but for browsing vegetation. The terrifying claws, once thought to be weapons, were tools for pulling down branches, stripping leaves, and possibly defending against predators when threatened. The revelation stunned the paleontological world. How could one of the strangest plant eaters in history evolve claws that looked more at home on a horror movie monster? The answer lies in evolutionary improvisation. Therizinosaurus was part of the same broad group of dinosaurs that gave rise to predators like Velociraptor, but it diverged into a wholly different ecological niche. Instead of eating meat, it became a specialist browser, adapting claws for gathering food in ways no other dinosaur did. Yet the sheer scale of those claws ensured that even as a herbivore, it looked like a nightmare. Therizinosaurus itself was enormous, reaching lengths of 33 feet and weighing several tons. Its long neck and pot belly gave it an ungainly, almost alien appearance. Reconstructions show a creature with shaggy, feather-like coverings, a small head, and arms outstretched with claws like agricultural tools. To human eyes, it looks like a monster that stepped out of folklore, a grim reaper stalking the ancient floodplains. But in reality, it was a gentle giant compared to its predatory cousins, using its formidable claws to feed rather than kill. Paleontologists remember the first time they saw those claws as one of the scariest events in the fossil record. It was like staring into the unknown and making up animals that never existed when you found claws longer than swords. Even after the truth came out, the thought of seeing a dinosaur with claws that are 3 feet long is still scary. It's hard for evolutionists to believe that such an animal could exist at all. There is also evidence that Therizinosaurus used its claws for more than feeding. They may have been display structures, intimidating rivals or attracting mates. They may have served as defensive weapons, allowing the otherwise slow and vulnerable dinosaur to slash at predators like Tarbosaurus that threatened it. In this way, the claws may have been multi-purpose tools, both practical for feeding and terrifying enough to dissuade attackers. Misunderstandings, wonder, and a lesson of how incomplete proof can lead people astray are all part of the story of the Therizinosaurus claws. For 50 years, paleontologists only saw the weapons and thought there was a monster. Even stranger was what the full skeleton showed, an evolutionary oddball that made it hard to tell what was dangerous and what was safe. That vegetarian had the tools of a killer is proof that nature's trials aren't always simple. Pliosaur skull, sea monster of Dorset. In 2009, a fossil hunter came across something amazing sticking out of the rock on England's famous Jurassic coast. The cliffs were falling. It looked like a head, but not the kind you'd expect from a known animal. This fossil was almost 2 meters long and had jaws that were thick and full of teeth as big as bananas. It belonged to a Pliosaur. which was a sea creature that lived 150 million years ago and lived in the oceans. As paleontologists looked at it, they realized they were seeing one of the scariest sea creatures that had ever lived. Pliosaurs were a branch of plesiosaurs, but while their cousins had long necks and small heads, pliosaurs evolved in the opposite direction. They had short, muscular necks, giant skulls, and enormous jaws designed for power. The Dorset skull, nicknamed the Monster of Aremberry by some researchers, was a chilling confirmation of their dominance. This single head measured more than 6 feet in length. The full animal may have stretched over 40 feet long, its body propelled through the water by 4 massive, paddle-like flippers. The bite force of a pliosaur has been compared to that of a modern crocodile, but on a scale several times greater. Estimates suggest it could exert tens of thousands of pounds of pressure, enough to crush bone and shear through prey with ease. The teeth, conical and sharp, were designed not for slicing, but for gripping. Once its jaws closed, there was no escape. Paleontologists believe pliosaurs fed on anything they could overpower: giant fish, squid-like cephalopods, other marine reptiles, and even smaller plesiosaurs. Fossil evidence of tooth marks on bones supports the idea that these were apex predators, feared by everything else in the Jurassic seas. What was so alarming about the Dorset find was how well it was kept. The head was very powerful, even when it was broken up. The spaces for the jaw muscles were very big, and the bone ridges were thick and strong. When paleontologists stood next to the fossil, they thought they were not looking at a relic, but at the body parts of an animal that was still ready to attack, to the point where one expert said it gave him chills. Studying it was like staring at the face of a dragon that actually lived. The Jurassic coast itself has long been a treasure trove of marine reptile fossils, first made famous in the 19th century by pioneering fossil collector Mary Anning. But this skull dwarfed almost everything else found there. It proved that Britain's seas once hosted predators rivaling the great dinosaurs on land. And unlike dinosaurs, which could only move on solid ground, pliosaurs could attack from any direction in the water, striking upward from the depths or lunging sideways with terrifying speed. The anatomy of pliosaurs added to their reputation as perfect killing machines. Their streamlined bodies allowed them to cut through the water like torpedoes, while their 4 flippers worked in tandem to provide bursts of acceleration. Studies suggest they were agile hunters, capable of pursuing prey rather than relying solely on ambush. Combine that speed with jaws over 6 feet long, and you have a predator capable of bringing down almost anything in its environment. For paleontologists, the Dorset skull was also a sobering reminder of how much we still don't know about ancient oceans. Fossilization favors creatures with bones that settle in sediment, but vast numbers of marine reptiles must have vanished without leaving a trace. If a pliosaur of this scale could remain hidden until the 21st century, what else might be waiting in cliffs and seabeds around the world? The thought is both thrilling and terrifying. Culturally, pliosaurs have fueled many myths of sea monsters. Stories of giant reptiles lurking beneath the waves have haunted sailors for centuries, and fossils like this give those legends a grounding in reality. To stand before the skull of a pliosaur is to understand why ancient people believed the oceans were filled with dragons. These were not exaggerated myths, they were echoes of real monsters from deep time. The pliosaur fossil from Dorset is now one of the biggest and most complete ones ever found in Britain. It has helped us learn more about how these dangerous animals lived and killed, but it has also made us feel even more uncomfortable around them. Pliosaur bones are huge and scary, even though the animals are long gone. Gigantopithecus teeth, King Kong's cousin. Ralph von Königswald, a German geologist, went into a Chinese drugstore in the 1930s and saw something strange among the jars of traditional medicine. Huge preserved teeth, much bigger than any human molars, were being sold as dragon bones. He bought them out of curiosity and started to look at how they were put together. He was shocked to find that they didn't belong to an old dragon or a magical beast, but to a giant ape he had never heard of. People first learned about Gigantopithecus blacki, the world's largest ape, when it was found by accident. From just a few teeth and later a handful of jaw bones, paleontologists reconstructed an animal that dwarfed modern gorillas and orangutans. Estimates suggest Gigantopithecus stood over 10 feet tall when upright and weighed close to 1,000 pounds. a primate so massive it could have looked a person in the eye while towering above them. To put it in perspective, the largest silverback gorillas alive today weigh around 400 pounds. Gigantopithecus was more than twice that size, a true giant of the Pleistocene jungles. What terrified paleontologists wasn't just the scale of the animal, but its proximity to us in evolutionary terms. This wasn't a reptilian monster from the Mesozoic or a sea predator from the Jurassic. This was an ape, part of the same family tree that produced humans. And it lived surprisingly recently, between 2 million and 300,000 years ago, well within the time frame of early human ancestors. That means our distant relatives may have encountered Gigantopithecus in the dense forests of southern China, Vietnam, and India. The thought of Australopithecus, or Homo erectus, crossing paths with a 10-foot ape is as chilling as it is fascinating. The fossils are nearing completion, which is very tempting. In tropical settings, ape remains rarely stay whole, unlike bones, which can fossilize as whole skeletons. We only have teeth, huge molars with thick enamel, and pieces of jawbone. Paleontologists think that Gigantopithecus had a big, strong jaw and ate a lot of tough plants like bamboo based on these pieces. People have compared them to current giant pandas, which eat bamboo and do very well at it, even though their ancestors were predators. It's possible that Gigantopithecus played a similar role, using its huge size to rule the forest floor while eating plants. Could an ape that large survive on vegetation alone? Some researchers speculate it may have supplemented its diet with fruit, or even small animals when necessary. Either way, its sheer size would have required enormous daily intake, hundreds of pounds of food per day. This reliance on bamboo may have sealed its fate. As climates shifted and forests shrank during the ice ages, Gigantopithecus may have faced starvation, unable to adapt quickly enough to changing resources. The possibility of coexistence with early humans continues to haunt researchers. Legends of enormous, hairy, man-like creatures, Bigfoot in North America, the Yeti in the Himalayas, the orang pendek in Southeast Asia, are sometimes speculated to be cultural echoes of ancient encounters with Gigantopithecus. While science firmly places its extinction hundreds of thousands of years ago, the overlap in geography and time with our ancestors is enough to stir the imagination. Did early humans fear this towering ape? Did they compete for food? Or did Gigantopithecus avoid them altogether, disappearing quietly into extinction? What makes Gigantopithecus especially unsettling is how little we know despite its immense size. Dinosaurs leave behind bones, tracks, even skin impressions. Gigantopithecus, though far more recent, remains a ghost in the fossil record. The scarcity of remains suggests that entire populations vanished without a trace. This gap in knowledge frustrates paleontologists and fuels mystery. It's one thing to reconstruct the life of an animal that lived 150 million years ago. It's another to have so little evidence for a giant ape that walked the Earth just 300,000 years ago. Anomalocaris fossils, alien predator of the Cambrian. In the early 1900s, when paleontologists first started digging up fossils from the Burgess Shale in Canada, they found pieces of strange animals that didn't seem to fit into any one group. One specimen looked like a shrimp's body, with different parts. One looked like the mouth of a crab. A third one looked like the tail of an unknown insect. Scientists kept these strange pieces in separate files for decades because they thought they came from different species. They didn't realize the scary truth until much later. All three belonged to the same animal, a killer that looked like it came from another planet. Its name, Anomalocaris, means strange shrimp. Anomalocaris lived during the Cambrian period, over 500 million years ago, at a time when complex life was just beginning to explode in diversity. The Cambrian seas were filled with bizarre organisms unlike anything alive today. Trilobites scuttled across the sea floor, early worms wriggled in sediment, and sponge-like creatures filtered water. But towering above them all was Anomalocaris, the first true apex predator in Earth's history. At over 3 feet long, it may not sound enormous, but in a world dominated by small, soft-bodied animals, Anomalocaris was a giant. Its anatomy was so strange that it still unsettles researchers today. Instead of a rigid jaw, it had a circular, pineapple slice-shaped mouth lined with plates that could rotate and clamp down on prey. Two long, spiny appendages jutted forward from its head, snapping shut like barbed arms to seize trilobites and other animals. Its body was segmented and flexible, lined with rows of swimming lobes that rippled like fins, allowing it to glide gracefully through the water. And unlike most animals of its time, it had large, stalked, compound eyes with thousands of lenses, granting it vision sharper than almost anything else in the Cambrian Ocean. To think of an Anomalocaris hunting is to picture something completely strange. It would float above the seabed and watch for movement. When it saw one, it would lunge forward and snap its hooked arms around a trilobite. The prey would be flipped toward its spinning mouth, where hard plates would crush and tear it apart with a twist of its flexible body. Trilobite shells that have been fossilized have bite marks that exactly match the strange circle pattern on Anomalocaris' jaws. It was a nightmare for animals that had never been attacked by a killer so skilled. Paleontologists felt uneasy when they found Anomalocaris, not just because of its shape, but also because of what it stood for. It was the start of complicated predation, which means it was the first time an animal developed to hunt and control other animals. It wasn't long ago that most living things were filter eaters, grazers, or simple scavengers. Because it was so big, fast, and could see well, Anomalocaris changed the way ecosystems work by starting an arms race between predators and prey. The fact that trilobites got hard shells may have been a direct evolutionary response to the danger that Anomalocaris offered. Reconstructions of this creature look like something out of science fiction. With its long, grasping arms, bulbous eyes, and circular jaw, it resembles no animal alive today. Holding its fossilized parts in hand, paleontologists once thought they were dealing with several unrelated species, because the idea of one creature combining all those traits seemed too bizarre to believe. The eventual realization that they belonged together was as awe-inspiring as it was unsettling. Earth's earliest seas were ruled not by fish or sharks, but by an animal so alien it still feels out of place in our history. The alien quality of Anomalocaris has made it an icon of the Cambrian explosion, a period when evolutionary experimentation produced body plans so strange that many have no modern equivalents. For scientists, it highlights just how unpredictable life's story really is. Had different evolutionary pressures prevailed, perhaps the world would have remained dominated by arthropod-like predators rather than vertebrates. The discovery of Anomalocaris is a reminder that Earth's history could have unfolded in radically different ways, and that our own place in it is far from inevitable. Fossils of Anomalocaris have since been found not only in Canada, but also in China, Australia, and other parts of the world, confirming its role as a widespread predator. Each new find reinforces the same unsettling idea. For tens of millions of years, Earth's oceans were ruled by a creature that looked more like an alien invader than anything we know. Quetzalcoatlus wings, the sky titan. In the early 1970s, a group of graduate students from the University of Texas exploring the Big Bend area of West Texas came across something truly amazing. In the brushy areas and dusty rocks, they found pieces of ancient bones that were so light and thin that they broke easily when touched. The kids thought at first that they had found parts of a big bird, but paleontologists found out the truth was much scarier when they looked at the bones. They found the wings of Quetzalcoatlus northropi, which is the world's biggest known flying animal. Named after the Aztec feathered serpent god Quetzalcoatl, this pterosaur reached wingspans estimated at 35 to 40 feet, the size of a small airplane. Its body stood as tall as a giraffe, with a long, toothless beak that could spear fish or snatch small animals from the ground. For paleontologists, the discovery was a revelation. It proved that flight in prehistory reached scales no bird has ever matched. But it also raised a deeply unsettling question. How could something so enormous actually fly? The fact that Quetzalcoatlus had a body only added to the enigma. Its bones were hollow and as thin as paper, which made it lighter but more fragile. It had long, thin wings made of a material that was stretched taut across its fingers. Quetzalcoatlus probably got into the air with strong quadrupedal vaults, using both its back legs and big front legs to jump high all at once. This is different from birds, which flap their wings to get airborne. Once it was in the air, it could fly for hours on thermals, going long distances with little effort. Even experienced researchers are scared by this picture of a giraffe-sized predator jumping into the air and flying quietly over them. Most of the time, we think of the sky as the home of small, weak animals, bugs, birds, and bats. But in the late Cretaceous, giants roamed the skies. They could pick up their food from the ground or the water and fly away without any trouble. Imagine being on an open plain and seeing a shadow that goes across the ground. When you look up, you see a lizard circling above you with wings that are longer than your house. What Quetzalcoatlus ate is still debated. Some paleontologists argue it was a scavenger, striding across floodplains on its stilt-like legs and picking at carcasses with its long beak. Others believe it hunted actively, swooping down to grab small dinosaurs, baby animals, or fish. Either way, its sheer size meant that it sat at the top of its food chain, ruling both the skies and the land it traversed. Unlike smaller pterosaurs, which may have been vulnerable to predators, Quetzalcoatlus had little to fear. The discovery also forced scientists to confront the limits of flight. Aerodynamic studies show that even at maximum wingspan, Quetzalcoatlus was pushing the boundaries of what is physically possible for powered flight. If it had been any heavier or its wings any shorter, it might never have left the ground. In many ways, it was nature's ultimate experiment in flying giants, an animal existing right on the edge of what evolution could achieve. For paleontologists, this was both awe-inspiring and unsettling. It was a reminder that prehistoric life tested limits in ways modern ecosystems no longer do. Standing in museums today, people often gape at the skeletal reconstructions of Quetzalcoatlus, its neck arched high above them, wings stretching across entire galleries. But even these models cannot fully capture the terror of seeing it alive. Its skin would have stretched tight over hollow bones, its beak sharp and unyielding, its wings casting shadows over the landscape. It wasn't just large, it was alien, unlike anything that flies in our skies today. The very thought of it makes modern birds seem fragile and tame. What makes things more peculiar is how the late Quetzalcoatlus lived. It did well in the last few days of the Cretaceous, living with Triceratops and Tyrannosaurus rex. The giant was one of many that died when the rock hit Earth 66 million years ago. But the fact that it lived so recently in terms of geology and flew above environments that we know makes it feel almost too close to be safe. It's not some strange deep Cambrian thing. Like a very modern killer, it would have made a person feel very small if they saw it. Thylacosmilus skull, saber-toothed marsupial. Paleontologists were shocked when they found Thylacosmilus's head for the first time in Argentina in the early 1900s. At first view, it looked a lot like the well-known North American saber-toothed cats, like Smilodon. It had long, curved upper canines that stuck out past the lower mouth. Each one was very sharp, able to cut through skin with surgical accuracy. It had a thick, broad head with a jaw hinge that was extremely wide. This let its teeth swing open in a dangerous arc. The surprise was that Thylacosmilus wasn't even a cat. What it was a marsupial, which is a totally different type of animal. It looked like saber-toothed killers had evolved twice, once on each continent, and from two different animal groups. This eerie phenomenon is called convergent evolution, where unrelated creatures evolve similar features to solve the same problem. In this case, the problem was how to bring down large prey. Smilodon in North America and Thylacosmilus in South America arrived at nearly identical solutions: dagger-like fangs, strong neck muscles, and wide gaping jaws. For paleontologists, this was both fascinating and unsettling. It meant that the saber-toothed design was so effective as a killing strategy that it evolved independently, as if nature itself was drawn again and again to the same frightening blueprint. The skull of Thylacosmilus added even more strangeness to the picture. Unlike cats, which grow their teeth from roots, its saber canines grew continuously, like rodent incisors. This meant its fangs were always lengthening, constantly regenerating as they wore down. To accommodate this growth, the animal's lower jaw had evolved massive flanges, bony shields that projected downward, protecting the tips of its sabers when its mouth was closed. The result was a skull that looked almost grotesque, oversized teeth jutting into reinforced bone, a face seemingly designed around its own weapons. What terrified paleontologists was the implication for its hunting style. With fangs that long and fragile, Thylacosmilus couldn't simply bite and crush like a lion. Instead, it likely used ambush tactics, grappling prey with strong forelimbs and delivering precise stabbing bites to the throat or belly. Once its fangs punctured an artery or organ, the victim would bleed out quickly. It was less about brute force and more about surgical execution. In this sense, Thylacosmilus may have been even more specialized than Smilodon, a predator built for quick, lethal strikes that left no chance of survival. The environment it inhabited only amplified its menace. Thylacosmilus lived in South America during the late Miocene and Pliocene, between 10 and 3 million years ago. This was an age when the continent was isolated, home to bizarre and unique mammals found nowhere else. Herds of giant ground sloths, armored glyptodonts, and horse-like notungulates roamed the plains. Into this ecosystem stepped Thylacosmilus, the saber-toothed marsupial, filling the role of top predator in a land untouched by lions or tigers. Fossils suggest it was about the size of a jaguar, but with proportions that looked stockier and stranger, its powerful neck and forelimbs built entirely around deploying its deadly fangs. It showed that predators of terrifying efficiency weren't rare accidents of evolution. They were patterns, repeated across time and space. Even when continents were separated, even when evolutionary lineages diverged tens of millions of years earlier, life still found its way back to the same horrifying designs. For paleontologists, it was a chilling reminder that the natural world doesn't need to invent new monsters. Sometimes it simply reuses the same blueprints, proving that certain ways of killing are timeless. But Thylacosmilus also brought up tough issues. Some people disagree on how good it really was, despite how scary it looked. Some experts think that its overly specialized head and teeth that kept getting longer may have been evolutionary dead ends. When new rivals and predators came to South America after the land bridge between North America and South America formed, Thylacosmilus was no longer there. It may have been weak because it only used one way to hunt, not being able to react to changing prey or surroundings. In this way, the fossils are both scary and sad because they show that even the most dangerous animals can be weak when things change. Mosasaurus jaw, the ocean dragon. In the late 18th century, long before dinosaurs were known as a group, quarry workers in the Netherlands, near Maastricht, found something very strange. It was a huge skull, nearly 4 feet long, with jaws that looked like they were made to crush food. People in the area knew it was valuable but didn't know what it was. Lots of people had strong opinions about the fossil, and even Napoleon Bonaparte was interested. He took it with him when he conquered France and had it sent to Paris to be studied. This fossil was later named Mosasaurus, which means lizard of the Meuse River. Naturalists were scared to learn that dragons used to live in the world's seas. Mosasaurus belonged to a family of giant marine reptiles that thrived during the late Cretaceous, about 70 to 66 million years ago. Unlike plesiosaurs and pliosaurs, which had long necks or short, thick skulls, mosasaurs were built more like scaled-up monitor lizards adapted for the ocean. They had elongated, streamlined bodies, powerful tails shaped like paddles, and limbs transformed into flippers. At full size, Mosasaurus could stretch over 50 feet long, with a skull packed with double-hinged jaws and teeth designed to grip and tear. The jaws alone were an evolutionary marvel. Like modern snakes, mosasaurs had flexible skulls that allowed them to swallow prey much larger than their heads. Some species even had a second set of palatal teeth on the roof of the mouth, designed to grip prey and drag it deeper into the throat. This meant that once something was caught in a mosasaurus's bite, be it a fish, turtle, shark, or even another marine reptile, escape was almost impossible. The fossil skulls showed a killing machine engineered by millions of years of evolution to dominate its environment. Early paleontologists felt alarmed not only by the body, but also by what it all meant. Before Mosasaurus was found, a lot of scientists thought that fossils of big lizards were either animals that died in Noah's flood or distorted remains of animals that were still alive in faraway places. The Maastricht skull made them think about a new possibility. These were the leftovers of a world that didn't exist anymore, full of terrifying predators they had never seen before. For experts in the 18th and 19th centuries, that understanding was so scary that it made them feel sick. Mosasaurus was the most powerful animal in the Cretaceous seas, which adds to its mythical status. Fossil records show that it ate almost anything. Some gut contents have shown fish and squid that have only partially been eaten. Some show the bones of smaller sea animals. Because of its size and strength, it was at the top of the food chain. It was a marine apex predator that terrorized the seas during the last few million years of the dinosaur era. Imagine swimming in warm waters from the late Cretaceous and seeing the shadow of a 50-foot lizard moving quietly below you. Its lips are lined with sharp cone-shaped teeth that are ready to snap shut. The fossil record of mosasaurs has also revealed just how adaptable they were. Some species were relatively small, under 10 feet long, specializing in fish and small prey. Others reached monstrous proportions, ruling shallow seas across Europe, North America, and Africa. Their distribution was global, with mosasaurs turning up in fossil beds on nearly every continent. This global reach makes them one of the most successful groups of marine reptiles, expanding rapidly in the last few million years before the asteroid impact ended their reign. Modern reconstructions of Mosasaurus have been shaped not only by fossils, but also by their portrayal in popular culture. Films and documentaries often exaggerate their size, but even the most conservative estimates leave no doubt. This was an animal that dwarfed great white sharks. Paleontologists, comparing its bite to modern predators, estimate forces exceeding those of crocodiles, enough to shatter bone with ease. The reality is that mosasaurs would have been nightmares for anything that swam in their waters. The most horrifying thing about Mosasaurus is how much it looks like animals we know. It looks like a monitor lizard or a snake, which are living things we can still see, but its body is much bigger and scarier. When you look at dinosaurs, they seem far away and strange, but Mosasaurus looks like a current predator turned into a story. It's easy to picture its shape moving through the water like waves, its jaws gaping open in the darkness. Because it looks so familiar, it is one of the scariest fossil finds ever. It proves that Earth's oceans were home to more than just giants in the past. They were also home to monsters that seem eerily real. Entelodont bones, hell pigs of the Oligocene. Paleontologists were confused when they found the heads of Entelodont for the first time in Europe and Asia. With their long snouts and teeth grouped in a familiar way, the fossils kind of looked like pigs. But the sizes were off. They were off very much. The skulls were almost 3 feet long and had heavy, crushing teeth and sharp canines all the way around them. The jaw muscles were connected to ridges that were so big that the heads looked like they were armored. These pigs were not like other pigs. Scientists named them entelodonts, but most people just call them hell pigs because they look so scary. Entelodon lived during the Oligocene epoch, about 37 to 28 million years ago, across Europe and Asia. Its North American cousins, such as Deinocheirus, extended the family's reign into other continents. These animals were omnivores, but not in the harmless sense of modern pigs rooting for tubers and acorns. Entelodonts were massive, standing nearly 6 feet tall at the shoulders, with long legs built for running and skulls that looked almost grotesque. Their cheekbones flared outward, their snouts were elongated and reinforced, and their jaws were armed with teeth capable of cracking bone. When paleontologists found Entelodon, it was shocking because it meant they had to face a killer that was hiding in plain sight. These weren't big bears or sleek cats. They started out as animals that looked like pigs and turned into scary, greedy killers. Fossil evidence shows that they were violent scavengers who could scare off other predators from kills. When the chance came, they were also active hunters. Like modern hyenas, their jaws were strong enough to break bones open to get to the marrow inside. Their long legs suggest they could run down food on open fields. Think of a pig that is 6 feet tall and has the speed and bite of a pack of wolves. The skulls themselves remain some of the most frightening fossils in mammalian paleontology. The enormous zygomatic arches, cheekbones, suggest incredible bite strength. The snouts carried scars and fractures, evidence of violent fights, perhaps between males competing for dominance or territory. In some specimens, broken bones had healed, meaning these animals survived brutal combat. To paleontologists, it painted a picture of a world where hell pigs ruled the land, not just through size, but through sheer ferocity. The way Entelodon's body was built added another gruesome factor. Modern pigs have barrel-shaped bodies and aren't very tall. Entelodon, on the other hand, was tall and skinny, with long legs that ended in cloven feet. It looked like a weird nightmare because it was half pig, half horse, and half killer. Reconstructions show a monster with a huge head that doesn't fit with its body. It looks like a skull on stilts that is walking. This disgusting mismatch between the head and body scared scientists and added to its scary name. Entelodon's diet also highlighted its adaptability as an apex omnivore. It likely fed on plants when necessary, but its jaws tell a different story, of scavenging carcasses, breaking bones, and possibly even cannibalism when food was scarce. Tooth marks on bones from fossil sites suggest they weren't picky, consuming everything from small mammals to large herbivores. In many ways, they were the hyenas of their time, but far larger and more imposing. For early paleontologists, this was chilling. An animal that looked like a pig, but behaved like a predator, blurring the lines between herbivore and carnivore. The nickname hell pigs was not given lightly. Standing eye to eye with a modern human, with jaws wide enough to bite through bone and legs that could cover ground quickly, Entelodon embodied the nightmare of the Oligocene. Unlike the dinosaurs, which feel distant and alien, these were mammals, our evolutionary cousins. They showed that even after the extinction of the great reptiles, Earth still produced predators of astonishing power and terror. Eurypterid fossils, the sea scorpions. In Germany in the middle of the 1800s, paleontologists found fossils of arthropods that looked at first like big scorpions. The segmented bodies, joined legs, and grabbing pincers looked like they did before, but the size was frightening. Some of them were almost 8 feet long and had clawed arms and legs that could wrap around a person's body. These scorpions were not like other ones. They were Eurypterids, which are commonly called sea scorpions. They were some of the biggest arthropods that have ever walked or swum on Earth. Eurypterids lived between 470 and 250 million years ago, thriving in the Paleozoic seas, rivers, and lagoons. At their peak, they were dominant predators, filling niches that would later be occupied by fish, crocodiles, and eventually mammals. Their bodies were armored with tough exoskeletons, and they had paddle-like limbs for swimming, as well as spiny appendages for grabbing prey. While some species were small, no longer than a human hand, others, like Gigantopithecus rhenanii, grew to monstrous sizes, making them the undisputed giants of their age. Not only were they huge, but they also ruled their environments, which freaked paleontologists. They were the top hunters and ate trilobites, early fish, and smaller Eurypterids. Fossil tracks show that they may have been able to get on land and move slowly along the shoreline like protected tanks. Imagine an animal that looks like a 6 to 8 foot scorpion crawling from a small pond onto old mudflats. It would be like a bad dream come true. The anatomy of Eurypterids was equally unsettling. Their large pincers could snap shut on struggling prey, dragging it toward their mouthparts for shredding. Their compound eyes, set high on their heads, gave them a wide field of vision, perfect for detecting movement in murky water. And their armored bodies provided defense against anything that might try to attack them. Combined, these traits made them efficient hunters, part scorpion, part crab, part nightmare. A single Gigantopithecus claw was found in a cave in Scotland. It is one of the most startling fossils ever found. Just one of the claws was almost half a meter long, which suggests that the whole animal was as scary as a contemporary great white shark. In the hands of paleontologists, that claw felt like the cut arm of a monster. There was physical proof that the Paleozoic world was home to huge, scary animals. Their gigantism is partly explained by the high oxygen levels of the Paleozoic atmosphere. Just as oversized insects and millipedes thrived during this time, arthropods like Eurypterids could grow to sizes that would be impossible today. But that scientific explanation does little to ease the instinctive fear these fossils provoke. For humans, scorpions and crabs are already unsettling in their alien forms. To imagine them scaled up to the size of a man is to imagine something deeply disturbing, as though evolution had taken familiar arthropods and pushed them into monstrous extremes. The discovery of Eurypterids also challenged long-held assumptions about the history of life. Before fish and amphibians rose to dominance, the oceans were ruled not by vertebrates, but by arthropods. This meant that for tens of millions of years, the top predators of Earth were not ancestors of mammals or reptiles, but armored scorpion-like hunters with claws that could shear flesh and exoskeletons that made them walking fortresses. For paleontologists, this was a sobering realization. The story of life is not just about our lineage, but about other branches that once ruled with equal, if not greater, success. Ammonite death assemblages, spiral graveyards. If paleontologists happen upon a bed of ammonite fossils, it is both beautiful and scary to look at. The scene looks like an ocean of swirls turned to stone at first glance. There are thousands of curved shells, some as small as a coin, and others as big as a car tire, packed closely together in layers of rock. This isn't a chance deposit though. They are death groups, or mass graves, of extinct marine animals that were wiped out by rapid, terrible events. For experts, they are scary memories of how quickly and violently species can go extinct. Ammonites were cephalopods, relatives of squids and octopuses, encased in hard, coiled shells. They thrived in Earth's oceans for over 300 million years, evolving into countless forms with intricate shell patterns and shapes. Some species were tiny and delicate, others massive and armored. They were a staple of marine ecosystems, prey for larger reptiles and fish, and hunters of plankton and small creatures. To find one ammonite fossil is expected. They are among the most common fossils on Earth. To find thousands clustered together in a single slab of rock is something else entirely. It suggests catastrophe. Death assemblages of ammonites have been found around the world. In Germany, England, Morocco, and even the Himalayas, where ancient seas once lay. These fossil beds often show ammonites of all ages and sizes, piled together as if swept into place. Some are preserved with their shells intact, others fragmented, suggesting they were violently tossed about before burial. For paleontologists, the question is always the same. What happened here? The answer is usually disaster. In some cases, volcanic eruptions may have choked the seas with ash and toxins, suffocating ammonites in massive numbers. In others, sudden changes in ocean chemistry, such as anoxic events that stripped water of oxygen, left entire regions uninhabitable in a matter of days. Fossil evidence even points to tsunamis or storm surges, sweeping ammonites into heaps, their shells dragged and broken before settling. Each assemblage is a frozen snapshot of destruction, a record of ecosystems collapsing in real time. What makes these sites so chilling is their scale. Ammonites were prolific, and their deaths often represent not just individual species, but entire communities erased at once. For paleontologists, standing before a slab containing hundreds of spirals is like standing in a mass grave. Each shell is a life, and together they speak of an event so overwhelming that nothing survived. These fossils are not just remnants of ancient animals, they are memorials to extinction. The most exciting part of the Ammonite story ends at the end of the Cretaceous period, which was about 66 million years ago. When the rock hit Earth, it caused the mass extinction that killed off all the dinosaurs that were not birds. Ammonites were also killed off. They had lived through many disasters before, like volcanoes erupting, changes in the weather, and oceans losing oxygen, but the last blow was too much. All Ammonite species had died out by the end of the Cretaceous. They suddenly went extinct, which paleontologists see as one of the clearest examples of how even the most successful species can go extinct in the face of a world disaster. The beauty of Ammonite fossils only deepens the unease. Their shells often display intricate ribbing and ridges, forming natural spirals that are mathematically perfect. Some are iridescent, their surfaces shimmering with opal-like colors even after millions of years. To hold one is to hold both art and tragedy. The remains of a creature that thrived for hundreds of millions of years, extinguished in an instant. Fossil beds filled with them are breathtaking, but also haunting, because they are not just random deposits, they are tombs. Paraceratherium skeletons, the largest land mammal ever. In the early 1900s, paleontologists working in the deserts of Central Asia found bones that were so big they thought they belonged to a dinosaur. Huge leg bones, huge vertebrae, and pieces of brain pointed to an unimaginably large creature. The Mesozoic wasn't when these fossils were formed, though. The Oligocene era was around 30 million years ago, a long time after the dinosaurs died out. Over time, the puzzle parts came together to show Paraceratherium, the world's biggest land animal. Paraceratherium, sometimes called the giant hornless rhino, dwarfed every elephant alive today. Standing more than 16 feet tall at the shoulders and stretching nearly 30 feet long, it may have weighed between 15 and 20 tons. Its skull alone was over 4 feet long, housing massive teeth and jaws built for stripping leaves from treetops. With its long neck and towering frame, it could browse vegetation at heights no other mammal could reach, filling a role similar to that of today's giraffes, but on a scale that made giraffes look small. The sheer size of Paraceratherium is what makes its fossils so unnerving. Mammals are supposed to be limited by physiology. Their bones must support warm-blooded bodies, their lungs must fuel high metabolism, and their legs must withstand constant movement. Dinosaurs achieved gigantic sizes thanks in part to lighter bone structures and unique respiratory systems. Yet here was a mammal, built like a massive tank, rivaling some of the smaller sauropod dinosaurs in scale. For paleontologists, this discovery shattered assumptions about the limits of mammalian evolution. Unlike the predators and monsters often highlighted in fossil stories, Paraceratherium was not a killer. It was an herbivore, feeding peacefully on leaves, shrubs, and branches, but its size alone made it formidable. With no natural predators capable of challenging it, it roamed the plains and forests of Asia unopposed. Fossil evidence suggests it lived across a wide range, from Mongolia to Pakistan, adapting to different habitats. Its massive bulk meant it could travel great distances in search of food, shaping entire ecosystems as it moved. What frightening most wasn't that Paraceratherium was dangerous, but that it was even possible. How did that animal get so big? How did its bones hold up its weight? How did it have babies and raise them when they were so big? With each new fossil find, paleontologists had to rethink what biology could and could not do. The bones was thick and had straight, column-like arms that were made to hold up tons of weight. The ribs were also very strong, carrying a body that was over 30 feet long from nose to tail. It had a frame that looked a bit like an elephant's, but it was much bigger than any living thing we've seen. The end of Paraceratherium is still unveiled. During the Oligocene, when the Earth was warmer and warmer, it did very well. During that time, wood spread across Asia, but as temperatures dropped and fields grew, it may have had fewer places to find food. There is a chance that competition from smaller, more flexible eaters played a part. Some experts think that its size, which was once its biggest strength, turned out to be its worst trait. If an animal needs hundreds of pounds of plants every day, it can't stay alive when ecosystems change in ways that hurt it. In this way, the fossils of Paraceratherium are a depressing warning that a species can still go extinct, no matter how big or strong it gets. Paleontologists are both amazed and humbled by the discovery of Paraceratherium. The dinosaurs were not the last giants. Its bones show that they were still around. Long after they went extinct, evolution made new giants, animals that were bigger and could live longer. And while dinosaurs make us feel far away and strange, Paraceratherium makes us feel more connected to it. It was a warm-blooded animal with fur that lived in a world that wasn't too different from ours. This fossil is one of the scariest finds ever because it looks so much like something else and is so big. To stand beside a mounted reconstruction of Paraceratherium in a museum is to feel small in a way even dinosaurs don't always inspire. Its skeleton towers above visitors, dwarfing elephants and rhinoceroses displayed nearby. Looking up at its massive skull, one cannot help but wonder what it would have been like to see such a creature alive, striding across ancient plains like a living skyscraper. The thought is both awe-inspiring and frightening. Mammals are not supposed to get this big, and yet one did. Before we close, remember that these fossil discoveries are just glimpses into the vast and terrifying history of our planet, proof that life has always pushed the limits of size, power, and strangeness. If you enjoyed this journey into Earth's prehistoric past, make sure to like this video, subscribe for more deep dives into history, science, and mystery, and don't miss our next video. It may not be about creatures at all, but it will open your eyes to another extraordinary corner of our world.